Hi, I'm Jim Heffron. These are my lessons in Calculus 1. We're going to do the homeworks for the chain rule. The chain rule is very important and also gives a lot of people trouble. So we're going to do problems that are mostly just drill, just trying to practice using the chain rule. Of course, as usual, the first problem is going to be from another section, but after that we're just simply doing number 3, number 5, number 7 kinds of problems. Okay, let's get started. Let's see, there we go. Let's see, so the very first problem is from another section. It is Chapter 2 review question, and again the book here is Stewart's Calculus book. Let's see here. Chapter 2 review, and it's number 5, and as usual I just simply plucked it out of a section, thought it looked like an appropriate question, trying to remind myself how to do questions from previous sections, and here it is. So the limit as x goes to minus 3 of x squared minus 9 over x squared plus 2x minus 3. I'll copy that to my paper. There we go. Limit as x goes to minus 3 of x squared minus 9 over x squared plus 2x minus 3. X squared plus 2x minus 3. And because this is a problem from a previous section, we recognize that we've done ones like this before, so we expect we have some idea what's going to happen. As you plug minus 3 into the denominator, you're going to find that you have a zero limit there, so that's not going to be just a matter of plugging in. So the limit as x goes to minus 3, and we expect that we have to do some algebra. I think I'm looking at x plus 3 and x minus 3 in the numerator, and in the denominator I think I've got x plus 3 times x minus 1. So, of course, when x approaches minus 3 limit, you don't actually have a value of x equals minus 3. So in that context, this fraction and this fraction are the same fraction. Okay, and now what's happening there, of course, is that you have a limit that no longer has a limit of a fraction that no longer has a limit of 0 on the bottom. So you can simply plug in minus 3, and I'll just slide the paper over. And we get minus 3 over minus 3 minus 1. So minus 6 on the top, minus 4 on the bottom, and we get 6 over 4 3/2. Okay, so as usual, the purpose of that question is to go back and bring it fresh up in our minds so that in this context, when you look at an exam, you say to yourself, oh yeah, I know how to do those, which is, of course, is a good feeling. But so then that brings us forward to section 3.4, and we're going to be doing number 9, number 11 kinds of questions, so drill questions, because the chain rule requires that we know some drill. So number 9 you can see is a composition, square root of 5x plus 1. Number 11 is another composition. It's 2t plus 1 to the minus 2 power. And number 15 is another composition, e to the x squared minus x. So a whole bunch of compositions. Just going to practice. That's all. No, nothing more complicated than straightforward practice. So number 9 is the derivative of 5x plus 1. F of x, the square root of 5x plus 1. Okay, so f prime of x is going to, I have to take the derivative of the square root part, and then I have to take the derivative of the 5x plus 1 part, and I'm multiplying the two together. So the derivative of the square root part, we've done an awful lot of these, is 1 over, there's a 2, and then there's a square root of 1/2 power. And what goes in here, of course, is not x. What goes in here is 5x plus 1. And then over here is going to go the derivative of 5x plus 1, so the derivative of what's inside. And the derivative of what's inside is simply 5. I suppose you could rewrite this. I suppose 5, and then on the bottom is a 2, and then a square root of 5x plus 1. The original question, 5x plus 1. The original question did have a radical in it instead of a 1/2 power, but anyway, that's all window dressing. Number 11. So 11 says g of t is 1 over g of t is 1 over 2t plus 1 quantity squared, t plus 1 quantity squared. So this is 2t plus 1 to the minus 2 power. Okay, so it's a function, namely the minus 2 power, applied to a function of t. So the chain rule, g prime of t is going to be take the derivative of the minus 2 part, minus 2 power part, and then take the derivative of the 2t plus 1 part. That part's easy. Derivative of the minus 2 part is minus 2, thinking ahead of myself, minus 3 power. And what goes in here is 2t plus 1, t plus 1. I see that there's a 2 and a minus 2, and I can combine them to make a minus 4, but really it's just fooling around. I suppose that if you want to put the answer in the same form as the question was asked, you would have minus 4 over 2t plus 1 cubed. Okay. So that was 11, so drilling. Next up is 15. 15 is g of x is e to the x squared minus x. G of x is e to the x squared minus x. Okay, so it is a function of x, namely x squared minus x, which is having a function applied to it. So it's e to the x squared minus x. I suppose if you wanted to, you could emphasize that by writing the exponential function applied to x squared minus x. In any event, the derivative g prime of x is going to be take the derivative of the e to the part and multiply by the derivative of x squared minus x, which is 2x minus 1. And the derivative of the e to the part is just e to the, it takes a little getting used to. So e to the, and I'm not writing e to the x, I'm writing e to the x squared minus x. Okay, so I think, it takes a number of these, a person has to do a number of these, but it's not super hard, it's just a question of getting used to it. 33, it is a capital F of t is e to the t times sine of 2t. E to the t times sine of 2t. Okay, so there is a function applied to a function. So off I go, see how we do f prime of t. So a chain rule, of course, calls for me to take e to the, and it's e to the, not e to the t, but rather e to the t times sine of 2t. And multiply times the derivative of t times sine of 2t. So I recognize that as a product rule problem. So you write down the first, take the derivative of the second, plus write down the second, take the derivative of the first. So the derivative of sine of 2t is going to be the derivative of the sine part and the derivative of the 2t part. Derivative of the sine part is cosine of 2t. Derivative of the 2t part is 2. Okay, now I don't want to lose track of what I'm doing here. Whoops. There we go, and there we go. So I'm doing the product rule. I wrote down the first, took the derivative of the second. Now I'm going to write down the second, sine of 2t, and take the derivative of the first. Okay, so it gets a little bit complicated because, oops, have to slide it over. Gets a little bit complicated because we have parts, and a person can do some simplifying. Probably you would write the 2 in front here, maybe all the way in front here. But in any event, it's a question of working your way inside. It's recursive. You sometimes have to take the derivative in order to take the derivative, but it's not. No one part is hard. It's just a question of sort of getting used to the do, and that's exactly what drilling is done for. All right, very good. All right, so next time we'll start in on section 3.5. Very good.